No problem with the gates, no problem with it has to be you have to get through G receptors or ligands. You don't have to have that. Apparently, you can just get in. Like for example, LNU employees or LNU students, you can get in the campus, right? Because you are students of and we are employees of LNU. But if you're an outsider, you might need additional features for you to be allowed to get in. Facilitated diffusion, right? And then active transport, definitely those that need carriers to be able to get in the cell. So how about signal transduction? We have certain neurotransmitters, okay, that you find at the cell surfaces, okay, and there must be signals for you to be able to get in, to be allowed to get in, okay. But take note that there are times that you don't need again a ligand. You don't need to be bound to a ligand for you to be allowed to enter the cell. Okay, again, this certain concept will be discussed in depth in your physiology. Was this already discussed, Dr. Salve, about the active transport, passive, facilitated?
Yes, Doc. We
So
have discussed that already.
all right, that's good. Okay, so I'm pretty sure you know what I'm talking about already. Thank you, Dr. Salve. So let's move forward. What are the receptors, the class of receptors of your signal transduction? I hope you had a really good foundation of this one. You have read your book in Vernon Levy or Guyton. This is asked in the boards. Okay, this is a board relevant question. So you have the ligand gated ion channels. So it depends on the charge that you have. Okay, the enzyme linked receptors. You also have the G protein coupled receptors, the secondary messengers, and then your steroid hormone receptor family. Okay, so I hope this was mentioned in your physiology because these are important, board relevant. So let's go with endocytosis. Just like us, we eat, diba? We endocytosis into, endo means into, cyto means cell. So the process of engulfing cells that are outside of the cell, substances that are outside of the cell, extracellular substances per se, and they bring it into the cytoplasm. That is your endocytosis. And we have three mechanisms for these. Easy, phagocytosis is the cell eating. Pinocytosis, you just drink, right? So imagine if you're going to eat a burger, that's phagocytosis. If you're going to sip your Coke, I don't know what your lunch was a while ago. So that's pinocytosis. And we also have the in receptor mediated endocytosis. Okay. So doctors, what do you think is this kind of endocytosis? Feel free to unmute. What do you think is this kind of endocytosis? Anyone?
Phagocytosis, lipase.
What? Sorry? Yes,
Phagocytosis.
that's correct. So phagocytosis. Look how this one, this certain, let's say this is a macrophage, like it's going to engulf this specific extracellular substance. So when you phagocytose, it doesn't mean that it's like a food or what. Usually, they are also harmful substances. Like a macrophage can engulf a bacteria. Okay, and that's true phagocytosis. If it's pinocytosis, the macrophage is going to produce harmful substances that will disrupt the cell membrane and will sift through the important cellular components of that offending organism and will perform pinocytosis. Okay, so the difference between phagocytosis, you just eat it as a whole. This the macrophage will eat as a whole, while your pinocytosis will have to disrupt first the barriers of the cell, like for example the cell membrane, in order to sift through the important components. Okay. So if we have endocytosis, we have exocytosis. And this is the one that will eject, so exit from the cell. Okay, we will be ejecting substances. Okay, usually these are the undigested materials. Okay, and also harmful substances that should be eradicated from the intracellular area. Okay, compartmentalization. We have this also to avoid the dilution of substrates. Okay, and importantly, you can see the compartmentalization when there are certain sensitive substances that have to be protected. Like for example, acute pancreatitis. Your acute pancreatitis can actually present or manifest like myocardial infarction, MI. When you say MI or myocardial infarction, that is actually heart attack. So there are those who will hold to the chest. What sign is that? You call that the Levine sign. Okay, when the person is having a heart attack, they will hold on to the chest. You call that your Levine sign, Levine or Levine, what have you. And what happens with your acute pancreatitis? There is a certain enzyme. You call it your trypsin. Okay, so in active form, you call it trypsinogen, but when it's active already, you call it trypsin. So it's actually a compartmentalized enzyme in the pancreas. So when you binge drink, when you binge eat, okay, so I don't know, maybe you're heartbroken or what, or you're just happy about something, you weren't able to regulate your drinking. So this trypsinogen will be activated to trypsin. And then the thing about your trypsin is it's an ultimate switch. When it gets activated, the rest of the digestive enzymes, there is a possibility that this will also be activated. That will cause autodigestion of pancreas and the neighboring organs. Okay, so acute pancreatitis, it's actually a life-threatening disease. I had a patient when I was a clerk. Okay, I was a junior intern, and we only had him for 5 days. He's actually a drunkard, so there was one time he had acute pancreatitis, very high blood pressure. Okay, that's why he had to be admitted, and of course it's acute pancreatitis. Um, every day headache, chest pain, abdominal pain, and then after 5 days he passed away. So please guard your health. Okay, I know you want to be doctors. Please drink responsibly, and not just that, buffets. Okay, it can also trigger. So eat moderately. Eat just enough. Okay, so let's move forward. Spatial temporal organization of the metabolic processes. So the membrane also has that. When we say spatial, it's the sense of the position. When we say temporal, sense of timing. So membrane also has that organized. Okay, God made it, so it's impossible that there's no God because each and every cell, each and every function, it's very detailed. It's impossible that there's no God. So all these, where is it going to happen? Metabolic process, where is it going to happen? Spatial organization. When is it going to happen? Temporal organization. So membrane functions encompass that. Okay, so they are passed from enzyme to enzyme. When am I going to activate this certain enzyme? So this is spatial temporal organization. I hope that's clear. And of course, the membranes are also functioning for storage, transport, and secretion, say for later use. So let's talk about the cytoplasm. Okay, doctors, is it okay if we have a 3-minute break? Just go back by 4:23.